Hello everyone. In this video, we shall discuss the first two types of functions, which are the constant and linear functions. So first, let us discuss what is a constant function. A constant function is defined as a function of the form y equals f of x equals k, where k is any real number. Now, the graph of a constant function is a horizontal line because whatever value of x we use, the value of y will always be equal to k. So which means that its point will be, or its set of points will be in the form x comma k. So which means that if we plot all those points, it will just form a pattern that will result into a horizontal line. Now the properties of constant functions, its domain is the set of all real numbers. So since the graph of a constant function is a horizontal line, its graph extends indefinitely to the left and extends indefinitely to the right. So which means that it covers every value on the x-axis. So that's why the domain is the set of all real numbers, or in interval notation, we write it as negative infinity comma positive infinity. Now, its range is just the set that contains the value of k, because in the graph, it's y equals k is the only y value that is being covered by the graph. Okay, and then the x-intercept of constant functions would depend on the value of k. Now, if our constant function is y equals 0 or f of x is equal to 0, that means this is k equals 0. So which means um, the graph of the function is a line, a horizontal line that is overlapping with the x-axis. So which means that all the points on the x-axis are considered as x-intercepts. Now otherwise, if the value of k is not equal to 0, then the horizontal line will never intersect the x-axis. So which means that the constant function has no x-intercept if k is not equal to 0. Now the y-intercept will always be the point 0 comma k. So for any real number k, even if k is 0 or not, the y-intercept will be the point 0 comma k. And then constant functions are neither increasing nor decreasing since its graph is a horizontal line. So let's have an example. Let us consider f of x equals 2. So this is a constant function because it is of the form f of x equals k, where k is equal to 2. So since constant function always has the domain as the set of all real numbers, so the domain will be the interval from negative infinity up to positive infinity. Now the range is the set that contains the value of k, and since in this case k is equal to 2, the range will be the set that contains y equals 2. Now since the value of k is 2, which is not 0, then there's no x-intercept for this constant function. And then the y-intercept is just 0 comma k, where k is equal to 2. So as you can see from the graph here, it's a horizontal line passing through the y-intercept 0 comma 2. And since this line doesn't intersect the x-axis, then it is verified that the function doesn't have an x-intercept. Now, if the function is f of x equals 0, this means that k is equal to 0. So again, its domain is still the set of all real numbers. So it's from negative infinity to positive infinity. Its range is the set that contains the value of k, which is 0. And since the graph of a constant function where k equals 0 is a line that overlaps with the x-axis, then that means the set of all points on the x-axis are the x-intercepts. And then the y-intercept is the point 0 comma 0. Now let's move to linear functions. What is a linear function? A linear function is a function of the form y equals f of x, which is equal to m times x plus b, where m and b are real numbers and n is not equal to 0. Because if m becomes 0, m times x will become 0, and the function will be reduced into a constant function. Now, linear function has a graph that is a straight line, which is not horizontal. And of course, it cannot be a vertical line because we're talking about linear functions. And a vertical line is not a function because it will fail the vertical line test. So for example, the following graphs that you can see on this slide are linear functions. The graph at the left side is a linear function that is sloping downward, while the graph at the right side is a linear function that is sloping upward. Now, in the given form of a linear function, the value of n is referred to as the slope of the line, and b is the y-intercept of the line. Now, if the slope is less than 0 or negative, then the line is sloping downward. Now, if the slope is greater than 0 or positive, then the line must be a line that is sloping upward. For the properties of linear functions, since the graph of a linear function is a graph that is either sloping upward and sloping downward, both of these graphs are extending to the left and to the right indefinitely. So therefore, the domain must be the set of all real numbers, which is represented by the interval from negative infinity to positive infinity. Now, for the range, since the graph extends indefinitely going up and going downward, not regardless if the graph is sloping upward or sloping downward, then its range will also be the set of all real numbers or the interval from negative infinity up to positive infinity. And also, the graph is continuously increasing when the slope m is positive, and it is continuously decreasing when the slope m is negative. Now, for the intercepts of the linear functions, so given the linear function y equals mx plus b, the intercepts are obtained as follows. So for the x-intercept, recall that we can compute it by equating the function to 0 and then solving for x. Now in this case, since f of x is m times x plus b, we're going to equate m times x plus b to 0, and then we solve for x. Transposing b to the other side, we get negative b, and then dividing both sides by m will give us x is equal to negative b over 10. And this is our x-intercept. Now for the y-intercept, we should evaluate the function at x equals 0. So we have y is equal to m times 0 plus b, and m times 0 is 0, and then 0 plus b is b. So that's why the y-intercept is 0 comma b. So for example, let's determine the intercepts of the function y equals f of x equals negative 3 times x plus 8. So again, for the x-intercept, we shall be equating negative 3x plus 8 to 0, and then we solve for x. So transposing 8 to the other side will give us negative 8, and then dividing both sides by negative 3 will give us x is equal to negative 8 over negative 3, which is also positive 8 over positive 3. So the x-intercept has coordinates 8 over 3 comma 0. Now for the y-intercept, we shall evaluate f at x equals 0. So we shall substitute 0 to x. So that's why we have negative 3 times 0 plus 8. And that gives us y is equal to 8. So the y-intercept is the point 0 comma 8. Next is, how do we graph a linear function? In graphing a linear function, it requires to have a straight line. And in order to graph a line, a minimum of 2 points are needed. So to graph, we can assign two values of x since the domain of a linear function is the set of all real numbers. We can take any real number x. So we can take any two real numbers and solve for the corresponding y values. Then, after that, we plot the 2 points on the Cartesian plane and connect them by a straight line. Now, in this case, we can also plot the intercepts and connect them by a straight line. So instead of thinking of two values of x, we can solve for the x-intercept and the y-intercept and then plot them on the Cartesian plane and connect them with a straight line. Now, moreover, we can also use the y-intercept of the linear function and use the slope value to get a second point. And then plot the points and then connect by a straight line. Now, to explain in more detail the slope of a linear function, remember the slope is denoted by m, and the slope measures the steepness of a line. So the steepness of a line is measured using the formula, the change in the y values over the change in the x values. And this is popularly known as the rise over run. So this means that if we have, let's say, a slope of negative 4 over 3, this means that the change in y is negative 4 and the change in x is positive 3. So for example, if we have a point of a linear function, then we can generate a second point by using the slope. So this means that if the change in y is negative 4, then from this point, we have to move 4 units downward, and then it's followed by positive 3, which is change in x, or a movement of 3 units rightwards. So this is the second point. So if this is point A, this will be point B. So these 2 points, A and B, are the points of the line. So if change in y is positive, then the movement will be upward. If change in x is negative, the movement will be leftwards. So we shall illustrate this later with an example. Okay, so for the first example, for graphing a linear function, let's sketch the graph of f of x equals 3x minus 4. So from the previous slide, it was stated that we can think of two values of x. So right now, let's use x equals 1 and x equals 3. We just substitute them into the function in order to get the y value. So if we substitute 1 to x, we're getting f of 1, which is 3 times 1 minus 4. And this is equal to 3 minus 4, which is negative 1. So that means the point 1 comma negative 1 is a point on of the line 3x minus 4. And in this case, 1 comma negative 1 is this point here. This is 1 comma negative 1. So from the origin, we shall move 1 unit rightward and then followed by 1 unit movement downward to get this red point here. And then when f is equal to 3, that's f of 3 equals 3 times 3 minus 4. So that's going to be 9 minus 4, which is 5. So that means we have the point 3 comma 5. So from the origin, we move 3 units rightwards and then 5 units upwards. So we get this second red point. So connecting the two red points, then that's the graph of our linear function 3x minus 4. Now also, instead of using this table of values, so we can make use of the y-intercept and the x-intercept. So for the y-intercept, we shall evaluate f of 0. So we have 3 times 0 minus 4, which is negative 4. So that means the point 0 comma negative 4 is our y-intercept. So that means from the origin, we have to move 4 units downwards to get this green point here. And then for the x-intercept, we will equate 3x minus 4 to 0 and then solve for x. So in that case, we have 3x equals positive 4 and dividing both sides by 3, we get x is equal to 4 over 3. So that's why our x-intercept is the point 4 thirds comma 0. So from the origin, we move 4 thirds units to the right. So 4 thirds is 1 and 1 third. So we have 1 unit and then 1 third. And then we don't move vertically because the y coordinate is 0. So connecting these two green points will also make up for the line dx minus 4. Now, if we have a second example, let's say sketch the graph of f of x is equal to negative 2 over 3 times x plus 1. Let's make use this time of the y-intercept and the slope. So from this function, we can easily determine that the y-intercept is 0 comma 1 because this is the value of b. Y-intercept is 0 comma b. And then our slope n is negative 2 thirds. So we have two options no, for n equals negative 2 over 3. This could be negative 2 divided by 3, or that could be positive 2 over negative 3. So let us use the slope negative 2 over positive 3. So first, we will plot the y-intercept, which is 0 comma 1. So from the origin, we move 1 unit upward. So this is the y-intercept. And then from the y-intercept, we shall generate a second point of the line. So the second point shall be determined through the use of the slope. So since the change in y is negative 2, from the y-intercept, we're going to move 2 units downwards. And then it's followed by a 3 unit movement uh, rightward because delta x or change in x is positive 3. So from this point, we shall move 3 units rightward to get this particular point here. So connecting these 2 points, that's the graph of f of x equals negative 2 over 3 times x plus 1. So there are three ways of graphing a linear function. First is through the use of table of values. Second is through the use of the intercepts. And third is through the use of the slope and the y-intercept. And then finally, the domain and range of linear functions. So as you can see, no, the graphs are both extending indefinitely from up to the left and to the right. And it extends also indefinitely going up and going down. So that's why in both of these graphs here on the screens, the domain and the range would be the set of all real numbers. So this ends the video about constant and linear functions. So I hope that you learned something from this video. And please do not forget to subscribe to my channel. Thank you for listening.